This video goes over question 4 of the area between curves assignment. Find the area bounded by the graphs of the indicated equations over the given interval when stated. Compute the answers to 3 decimal places. So we've got a vertically stretched, upward-facing parabola. It is moved over to the right some, and then we've got y equals 0, and we're going from -2 to +2. First thing I want to do is put this in the calculator, and I do need to start a new problem. Doc, 4 for insert, 1 for problem, 2 for a graph. And I'm going to put in the parabola first, 3x squared minus 7x. I'm putting in another function immediately, so I'm going to hit down arrow. And then this is going to be y equals 0. And that is the same thing as the x-axis. So you may be wondering, why can't I just find the area between the x-axis and the function? Well, there are a couple of problems with that. One is we're going from -2 to 2, so that's from here to here. And if we did go below the x-axis, I'll just go ahead and show you that for a second. Menu 6, 7, we're going to go 0 to 2, 0, enter 2, and I get a negative area. That does have meaning in calculus. It did not make any sense in geometry. So I'm going to go undo that, and we're going to do bounded area. Menu 6, 8 for bounded area. We're going -2 to +2. And I get a total area of 28. And I'm going to go ahead and put that in. I can't see all the way up, but I know the area is 28. So 28, enter to check answer. Good job. Now I'm going to just hit X, and I'm going to do this in the calculator page. But we're going to take a look at this. So from -2 to 0, our upper function is the parabola f1, and the lower function is f2, y equals 0. And then from 0 to 2, the upper function swaps. So f2 is the upper one, the parabola f1 is the lower one. So I'm going to add a calculator page, Control Doc, 1 for a calculator page, Shift plus, and we're going to go from -2, tab 0. Tab. Now my parabola is the upper one, so f1 of x minus f2 of x. I could have just put in 0 if I wanted to. Tab dx. Now I need to do another integral for the other part. I need to right arrow to break out of the little dx. Then I'm going to put in a plus sign, shift plus to get another integral. 0, tab 2, tab. Now the upper one is the line, y equals 0, so that's f2 of x. Could have also put in 0, minus f1 of x and dx, and we should get 28 again. And I'm not going to do this one by hand, so we can take a look at how complicated this is. And if we go back to the graph, that bounded area did a lot for us. It figured out which side was positive. This would have been negative if we were doing it just for an integral, and it figures out this is positive area, this is positive area. So that's kind of handy using bounded area. That concludes this video.